Hello, I'm Mike McCulloch. So today I would like to talk to you about the electron, which is one of the fundamental particles of physics, one of the most common ones. So negative charge orbits around the positive nucleus in the atom. But there are quite a few problems with it. So the normal theory of the electron is the Abraham-Lorentz one, in which it's regarded as a sort of solid shell of negative stuff surrounded by an electric field. And you can calculate the energy in the electric field that it carries with it. And you can do that with this formula here. So E is the energy, and it's the integral of epsilon naught E squared over 2 as with radius. And you can amend this using a value for the energy. So it's the integral from r, which is the radius of the solid part of it, out to infinity of E squared over other things divided by r squared. And if you multiply all this out, you do the integral, you get E squared over 8 pi epsilon naught r. So the energy of the electron increases as its radius decreases. The question is, what is the radius? Because if for example, the electron were to be a point particle, so the radius would be effectively 0, then the energy it would have would be infinite, which is obviously not correct. It would be impossible to move it for a start. So, but we do know the energy of the electron in other ways. We know the momentum it carries, that kind of thing, so we can work out the energy. And so we can work out the radius it must have so that the electric field associated with it has that energy that we know is associated with the electron. And the radius, if we assume that, is about 2 times 10 to the minus 15 meters, which is called the classical electron radius. But several experiments have been done over the years looking at the electrons scattering things from it, and these experiments have become more and more complex and accurate over the years, so that now we can be sure that the electron radius is less than about 10 to the minus 22 meters, which, as you may notice, is way smaller than the 10 to the minus 15 meters that the theory predicts. So this is a huge anomaly. So it's about 10 to the 7, a factor of 10 to the 7 different. So about 10 million times smaller than expected. So that's a big anomaly. So what's up here? Is there any better model we could have rather than this idea of Abraham-Lorentz that an electron is a pack of negative material, which is problematic anyway, because surely it would tend to explode, so they have to invent what are called Poincare forces to keep it packed in. So, which starts to sound a bit like a galaxy rotation problem, doesn't it, for the electron? So there are certain intriguing papers that have been written about this, suggesting that an electron could be a trapped photon. So I've read interesting papers by Jennison et al. I read that one a few years ago. And recently somebody on my Patreon suggested that I look at another one by Williamson and van der Mark. And what they say is that perhaps the electron is a trapped photon. So a photon that has somehow become trapped in a specific volume and is going round and round. And there are various routes that it could take. It could go in a circle, it could go in a figure of 8, for example. And these papers discuss that, but in these papers they don't give a reason as to how the photon could have become trapped. But quantized inertia might offers a way to do this, because if you have a photon and you cause it to move in a circle, then because it's traveling at the speed of light, the horizon that it sees as it goes in this circle will be the radius of the circle. So this photon will suddenly not see any of the universe outside it. It won't be able to see any or perceive or detect any of the universe outside it. So it would be able to become a completely independent entity. So the other thing is that if we do that, then we go back to the integral we had before. Now, instead of integrating from the radius of the sphere, the electron sphere, out to infinity, the integral would effectively be from the radius to the radius. So it would effectively be zero. There would be no energy contained in the field, because as far as the electron, or the photon, if you like, is concerned, there is no outside that radius. So the only energy that would be carried by the electron will be contained in the photon itself as it goes around, because of its wavelength and that kind of thing. And you can kind of picture this like this. So you've got the photon trapped in a circle or whatever it is, and the horizon, as you can see, is along the trajectory. So there's nothing effectively outside that. So in this way, quantized inertia might enable us to produce a boundary condition that would help to explain these theories of Jennison and Williamson and Mark, that the electron is a trapped photon. A horizon could be the thing that is trapping it. Okay, so I hope this short has managed to shed some light on the problem of the electron, and I look forward to doing another one for you tomorrow. Goodbye.